So here is a nice little summary of what we just talked about. Remember, I told you anytime it's an even function, meaning your degree is an even number, it will have the same n behavior as a parabola. When n is odd, or when it's an odd degree, it will have the same n behavior as a linear graph. So if I was you, I would definitely write all 4 of these bullet points down. I'm going to show you some graphs that will kind of explain why the n behavior works this way, depending on whether it's even or odd. But for right now, just copy this down, and we'll look a little more in detail at different graphs in a second. So I want to look at some graphs to see if we can explain why this is the case. So I'm going to zoom out a little bit so you can see as it gets bigger and bigger. So I'm starting with y equals x. So the lead coefficient is positive, and the function is odd. The exponent here is a 1. Okay? What is happening to the graph as I'm going farther and farther to the right? It's getting bigger and bigger and bigger. As I'm going farther to the left, it's getting smaller and smaller and smaller and smaller. Okay? So as the x value is getting closer to negative infinity, so is our graph. As the x value is getting closer to positive infinity, so is our graph. Now, that is also the case for something with an exponent of a 3. The graph will look a little different right in here, and we're going to investigate what's going on in here a little more later in the chapter. Probably actually after Christmas break. But you can still see, as your x values get bigger, so does your function. As your x values get smaller, so does your function. So even though the exponent is not the same, since it's an odd exponent, the n behavior of your graph is the same. Okay? This also holds true for x to the 5th, x to the 7th, x to the 9th, x to the 11th. You can see that any graph with an odd number exponent has the same n behavior as a linear graph. Any questions on that idea? Okay? The second you change that lead coefficient to a negative, everything switches. So now as your x value is getting smaller and smaller, your function's getting larger. And as your x value is getting larger and larger and larger, your function's getting smaller. Okay? So that's why the lead coefficient changes the n behavior. Let's go back to a positive lead coefficient, but let's look at when it's an even function. So when your degree is even, do you see how no matter which direction you're going, towards positive infinity or negative infinity, your graph is going to positive infinity, right? It's going up. The farther you get out, the higher it's getting. Okay? That holds true for any even exponent. You can see here we have x to the 4th. It's the same thing. X to the 6th. It's the same thing. X to the 8th. It's the same thing. What happens, though, when I change the lead coefficient to a negative number? It flips. Now, no matter which direction you're going, the end of your graph is pointing towards negative infinity. And again, we could change this back to x squared, and it would still be going towards negative infinity. So the two things you want to look at, the lead coefficient, whether it's positive or negative, whether your biggest exponent is even or odd. Any questions? All right, let's look at some examples. We don't have a lot of examples, there's just a couple. Here's our first example. So, describe the n behavior by completing the statement. F of x goes to blank as x goes to negative infinity. F of x goes to blank as x goes to positive infinity. Two things that are important are what? Yeah, positive and negative lead coefficient, even and odd exponent. Is this positive or negative lead coefficient? Negative. Even or odd? Even, right? You look for the biggest exponent, so it's even. This will behave in the same way that a parabola would if you had a negative in the front. We know that parabolas with a negative in the front open which direction? Up or down? Down. So both ends of our graph go towards what? If it's opening down, think of where your arrows are pointing at the end of your graph. Yeah, they're both going down. They're both going towards negative infinity. So f of x approaches negative infinity as x approaches negative infinity. So as you're getting farther on the left of your graph, also approaches negative infinity when you're going farther to the right on your graph. This line is the answer. The actual answer is, I guess, this part where we filled in the blank. And then this part would be this blank. Here's example 10. So again, we're filling in these blanks. So our function approaches what as x approaches negative infinity? So as we're going to the left on our graph, what's happening to our function? F of x is approaching blank as x is going to positive infinity. So as we're going to the right, what's happening to our graph? Two things we need to focus on. What are they? The same thing as last time. So is our lead coefficient positive or negative? Positive. Is our degree even or odd? Odd. This will behave in the same manner as a linear graph with a positive slope for its end behavior. So imagine a linear graph with a positive slope. It just looks like this. So as your x values are approaching negative infinity, as they're getting really small, where's your graph going? Down. So we would need a negative infinity in this blank. As your x value is approaching positive infinity, as it's getting bigger and bigger and bigger, what's happening to your graph? Going up. So that we need a positive infinity in that blank. Now, if you forget these rules, there's something you can always do. What is a number close to infinity? Pi, that's 3. 3 is not close to infinity. 1 trillion. 1 zillion. 100? Yeah. Do you think your graph is going to be changing very much past the little window that we usually focus on? Not really. Any number outside of, I'd say, like 50 will probably tell you what the end behavior is. Unless your coefficients are really big numbers, most of the change happens right around the origin. So if you want to test a number like 100 or 200 or 300 or 500 and see where the function is, that's fine. If you plug in 500 and you get negative 2,000, it's approaching negative infinity. It's not even close to negative infinity, but that's where it's headed. Okay? Yes, ma'am.
Okay, so if
here's our last example. So it just says match the graph with the polynomial function by observing its end behavior. So we don't know anything. We haven't learned how to graph this sort of graph or this sort of graph yet. So we can't judge really anything in the middle here. The only thing we've learned about is end behavior. So one of them has end behavior similar to a parabola. One of them has end behavior similar to a linear graph. Which one's which?
the one with the negative 4 is going to be the first one. Well, the parabolas are negative infinity.
I've heard lots of guesses. Anyone think they have it?
The first one.
The first one, what? I gave you an either or problem, I feel like.
Oh,
The first one is sort of like,
parabola. Is this a linear? What is our question?
the end behavior either looks like a linear graph
Oh.
or a parabola. Yes, the first The first graph represents the end behavior of a linear graph, right?
Yep.
In one direction it's going way down, the other direction it's going up, sort of like a line. Again, we're not worried about what's happening here in the middle today. We'll get there. What is the degree of a graph that has the end behavior like a linear graph? The degree has to be odd, just like a linear graph. So, which one goes with graph number 1? The first one. The degree has to be odd for it to behave like a linear graph. For the end behavior to represent or to resemble that of a parabola, like this one, how they're both going down, it has to have an even exponent.
Oh, but not like what we did a few days ago, right? Like that could be even or odd.
What we did a few days ago, I'm not sure what you're referring to.
Yesterday?
Yeah, yesterday we didn't look at the graphs at all.
Okay.
Today's the first day we're looking at the graphs. So, like I was saying, the second graph, the end behavior resembles that of a parabola, right? So it could only match a graph with an even degree, like the second equation. Questions? Yes. Your homework assignment tonight is to actually finish the homework assignment that you started yesterday, except now you know how to do all the problems. So work on that this weekend. We are doing a lesson we're doing a lesson on Monday. Tuesday we're going to spend a lot of time going over the Chapter 5 test. So expect homework one night next week, maybe 2, depending on how things go. But definitely Monday you will have homework in here.